Britain's railways transport 3 million people and 400,000 tonnes of freight every day, with hundreds of trains using the network at any one time. Thousands of components and systems are used to keep the railway moving, but arguably one of the most important components is probably the most humble: ballast. In this edition of Track Safety Matters, we take a closer look at the journey of ballast right from the quarry face to the forefoot, and consider some of the hazards associated with ballast dust. Cliff Hill Quarry is one of the sites that supplies the railway with ballast, and the process starts right here at the rock face.
In this site specifically, it's really the start of the process, and one of the first jobs they'll do is come down and use the laser scanner on the face to pick up all the overhangs, the intricacies of the rock. They'll then put that into a computer to design the rock and say exactly where each individual hole needs to go, and also the angle of the holes. Each detonation in each hole is controlled by a microchip, so that enables us to control to up to about 1 millisecond when each individual shot goes off within a full blast. The blast sizes that we do here typically are anywhere between 15,000 and 40,000 tonnes in one blast. We have two loading machines here. One's a backhoe excavator and the other's a loading shovel. They will pick the material up and put it into dump trucks, and they'll haul the stone all the way up out the quarry and to the primary crusher. The primary crusher itself is a gyratory crusher. When the stone's tipped into the crusher, the stone is forced onto each other, and it's the stone on stone action that actually reduces the size of the stone.
The quarries have been doing this for a long time, of course. It's their core business. It's producing aggregate, so they've got really stringent quality control processes in the crushing and screening processes that they use, and also in the testing protocol that they have. And they provide our colleagues in quality with a daily report on the quality of the ballast that is produced and offered to sale for us.
They will take a sample, they dry it, they take the shapes, they run it through a series of sieves, so they can see how much of each size and quantity is in the delivery to us. Dust is the main element that we're concerned with, especially with our colleagues on sites. It's 0.5% by weight, but what we are doing with the quarries is working with them to come down below the envelope, so we're working around about the 0.2, 0.3, but this is the aim with the quarries. Everybody's on board with this with us.
The whole thrust of managing a risk or a hazard is to eliminate it at its source. So as an industry, and that's where the Track Safety Alliance comes into its own, we really need to be concentrating on modern techniques for transporting this ballast to site when it's already been treated and the levels of dust are minimised at source.
When we're loading it out for delivery, it gets screened and it gets washed, and it means that when we're sending the product out, we're sending out a damp product so that there is no fugitive dust escaping.
The ballast, as I said, is unloaded at the local distribution centre, stockpiled and reloaded, so that all the time that you're handling it, the attrition can lead to ballast dust. So the team at the depots are checking the quality of the ballast on the stockpiles before it's loaded into the wagons, into the possession train wagons.
We worked with one of our suppliers and devised this thing here where we can add water to the ballast after loading, and these will deliver enough water to soak all of the ballast in the wagon.
We're also looking currently at the work we do with the Ballast Dust Working Group. They've got a tractor. That tractor has an arm that can come out and spray water, so we're looking at using that immediately on the site as the train pulls into the work site. Obviously that will reduce the ballast dust on site, won't prevent it, but it will certainly make it less.
One thing we have noticed is it's not just about the amount of dust within the ballast trains that we deliver to site, but also the potential for dust being liberated. We've seen evidence where guys may be dropping stone from significant heights, 15 to 20 feet. If this is the case, then we are massively increasing the potential for dust to be liberated into that working environment.
And part of the education process is when we unload the ballast from the wagons, is we do not drop it at height, that when the bucket goes into the wagon and takes out the ballast, that it actually lowers the bucket before dropping it. The second most important point is remove everyone from that workplace who is not required to be there. And the third point is that if you have to be in that work site, then we provide the appropriate PPE for these operators so that they will offer the required protection.
For certain people who are operating at the cutter bar area, it's a particular problem because the cutter bar is moving around, digging up the ballast and throwing up basically the ballast dust everywhere.
Well, I've worked on these ballast cleaners for approximately 7 years, and right from inception, right from the early days when I first started with them, I could see the hazard, and it concerned me, especially from my mining industry background, and I realised at the early stage that something needed to be done.
What we are presently doing is an exercise through the Ballast Dust working group to go actually out and measure the actual levels of silica. Once we have concluded our measurements, on-site measurements, we'll have an accurate picture of exactly what levels our people are being exposed to.
We've done the sampling, which is basically a little dosimeter that's put on the guy's shoulder. There's a little vacuum attached to that. That draws the ambient air over a little filter paper. That filter paper then gets analysed and tells you how much silica they've been exposed to.
The initial results are coming through now with supporting reports. We've got 4 activities from our local distribution centres where people are actually working day in, day out with stockpiles of ballast, loading wagons, right through to 12 site-related activities. And it's important that we have some hard facts. It will help us challenge and further develop the existing controls, risk assessments and general arrangements on site.
So it's really important that the industry take a precautionary approach and understand that the silica in ballast dust, it's not like general construction dust. You can't treat it as a nuisance dust. The workplace exposure limit for silica is 40 times lower than general construction dust, so we do need to see very tight standards and a precautionary approach.
We know quite a lot about silica in a historical sense because it used to be that people who worked, stonemasons for instance, would have an awful lot of exposure to silica on a daily basis, and these guys would get very nasty fibrosis in the lungs, silicosis very quickly, and that was very rapidly, could be under those kind of conditions, very rapidly disabling and then fatal. Happily, it's not as bad as that with something like ballast dust because clearly there's a variable silica content of the kind of quarry material anyway, but it still contains silica. You can still breathe it in, and that silica can then still damage your lungs, even if it doesn't do it in a dramatic or rapid fashion. It's fair to say that the general approach and opinion in the industry is, because we've not to date had any known cases of people suffering with silicosis in the industry, that potentially we may be wasting a lot of time by scaremongering, whereas in reality we do know from external industries that they have had some reported cases, and therefore as a duty of care we must improve the level of awareness. Because if people don't understand the reason for why they have to adopt these safe systems of work, then they're less likely to do it. So there is a need for sort of a cultural change within the industry where health issues are taken as seriously as safety issues, and that adopting these safe systems of work becomes the way we do it in the rail industry. There is a cultural issue where people don't perceive the same level of risk, and so they don't think that they're going to get poorly or going to see any adverse effects on their health, and will continue to do things the way they've always done so. Anybody that's thinking that it'll not happen to me, that mentality that we all have, that I'll be all right, it won't happen to me, I'm a big fit strong lad, and I just can't for the life of me see why people would think that they can get away without protecting themselves from that. You can say, well, I've been breathing this stuff in, I breathed it in yesterday. It's like having a cigarette. It doesn't immediately cause you to fall over or immediately, obviously, give you lung cancer. These things just increase risks over time. You can certainly develop obstructive pulmonary disease, obstructive lung disease, which means that your lungs don't work as well as they should. So you would get breathless at a different point compared with a fit person of your same age. And you do have an increased risk of lung cancer, especially if you're a smoker.
Through our education programme and teaching people on the hazards, they are also educated on here's the health risks, here's why we're doing it, here's why we're ensuring you have a good face fit, because if this dust gets into your lungs and are consistent, there is potential for long-term health effects.
Now we can manage this, but once the damage is done, we can't do an awful lot to undo it. So the answer really is to avoid exposure whenever you can. And if that means that you're working in the vicinity and there's a dust cloud and you don't need to be in it, then you just walk away and avoid it. And if you can't avoid that kind of risk because you are the operative and you're involved in whatever activity it is that's generating the dust, then you'll be provided with respiratory protective equipment and you really ought to be wearing it.
We're using different levels of PPE. If you're at the cutter bar area, it's an air-fed system. And obviously that's for that position because there's a high risk of the ballast dust at that point, and we know the silica content is quite high. The rest of the site, we've put people in FFP3 masks, which is the normal paper mask but with an FFP3 filtration system.
We've been working with suppliers of PPE. We've had and rolling out face fit training, again compliance with cost regulations. Our guys on the ground, it's no good having a face mask if they don't know how to wear it. So we are assisting with that programme and driving that through.
So to give protection, we've got to have good filter media and then a construction that seals well to the face. It's relatively straightforward to identify a properly certified FFP3, check that it's got the CE mark followed by a 4-digit number, and then find FFP3 on there. They're intended for use by clean-shaven wearers, so stubble and beards is out. Some other things people do wrong is just not take care in the day-to-day fitting, just pop it on. If it is a product that has a nose clip that needs to be formed to create a good seal around the nose, then not taking care with that, getting a bit slack. And the same with things like strap positions. Generally these types of products have 2 straps, and you do sometimes see people getting lazy and just using one, things like that. They should fit it by the book every time they fit it, is the message.
If you're wearing a tight-fitting dust mask, then you will need to have been face fit tested for that mask and be clean shaven to make sure that you get a proper face seal with the mask. If you've got a beard, or if you need to wear a mask continuously for more than an hour, then a tight-fitting mask won't really be suitable, and you will need a loose powered respirator.
So powered respirators are essentially a battery-powered fan and motor, and then with electronics monitoring the performance and alarms for things like low battery, low flow. You'll have a unit on the belt on the waist that's drawing the contaminated air in, capturing the stone dust on a filter, and then feeding the air up a tube into the headspace, so we get this constant flow of filtered air across the person's face and then out.
It's vitally important to wear these dust masks, whether people are uncomfortable or not. The understanding that these dust masks could actually save their lives or prolong their lives. I'm from like I've said, I'm from the mining industry, and the cemeteries of all the coal fields in this country are littered with young men that didn't wear dust masks or didn't protect themselves from this hazard.
We are therefore ensuring that our staff have got the right equipment, they wear that equipment, and that equipment is fitted to them. And the way we do that is face fit testing. They can then assure the people that they're wearing that face mask correctly, that mask is going to fit them and provide them with the mitigation and the defence that they need against the ballast dust.
And we would really encourage the whole of the track renewals industry to get behind the Ballast Dust Working Group, take part and use the guidance and the resources that they provided. There's some really good guidance, particularly on COSH assessments, to help make sure that your COSH assessments are risk-based and task-specific.
Well, we've got the suite of products I was referring to is on Safety Central under the National Delivery Service tab, and also there is additional information on the Track Safety Alliance website. So I would encourage you to visit both sites or either site to get more information.